NASA tried to destroy this watch. NASA failed. They baked it in extreme heat, froze it, stripped away the air around it, shook it violently, and subjected it to crushing acceleration. 3 chronographs entered NASA's brutal qualification testing: Rolex, Longines and Omega Speedmaster. The Rolex broke, the Longines broke, but the third watch kept timing. And that should not have happened, because this wasn't a space watch. It wasn't designed for astronauts. It was a racing chronograph built for life on Earth. Then, NASA strapped it to an astronaut and sent it toward the moon. So how did an ordinary commercial watch survive everything that NASA threw at it, when 2 of Switzerland's greatest names could not? To understand that, we have to go back to 1964. Imagine it's 1964. America isn't simply trying to reach the moon. It's racing the Soviet Union to get there first. Every mission matters, every launch matters, and every failure is being watched by the entire world. Inside NASA, engineers are preparing for missions unlike anything human beings have ever attempted. The spacecraft would be filled with advanced electronic systems, onboard computers, navigation instruments, communication equipment, and direct connection to mission control. But NASA is also thinking about what happens when the advanced technology stops working. What happens if an astronaut needs to measure a critical period of time and the spacecraft's electronic timer is unavailable? What happens when there is no replacement, no reset button, and no room for guessing? NASA wanted a backup that could operate completely independent: a mechanical wrist chronograph. Not because it looked impressive, and not because it carried prestige. Because a mechanical watch did not need power from the spacecraft. It didn't need a computer, and it didn't need a signal from Earth. The only thing it needed was its movement to keep running. Think about that. The most technologically advanced space program in history was preparing to place part of its trust into a collection of springs, gears, wheels, and levers, and small enough to fit around an astronaut's wrist. NASA didn't want promises from watch companies. It wanted proof. 3 mechanical watches, none of them purpose-built for the environment they were about to experience. NASA's question was brutally simple: which one will be still working after we've given it every possible reason to stop? These watches were not tested gently. They were exposed to extreme heat, freezing cold. They were subjected to near vacuum, high humidity, violent acceleration, shock, and relentless vibration. They endured acoustic testing designed to reproduce the deafening force of a rocket launch. And the test did not happen in isolation. The watches had to survive one punishing environment and then move directly into the next. No restoration and no careful servicing between rounds. No second chance, just survive. The Rolex didn't. During the humidity test, the Rolex stopped twice. Then, during the high temperature test, its chronograph seconds hand deformed. The hand bent far enough to interfere with the other hands, compromising the watch's ability to perform its most important function: timing. The Longines failed differently. Its crystal warped and separated from the case during the high temperature test. NASA tested another example. Its crystal also separated, but during decompression. 2 respected chronographs, 2 completely different failures. Both were eliminated. Hamilton was also considered. NASA had specifically asked for a wrist chronograph. Hamilton sent them a pocket watch. So before the torture testing even began, 4 watches had already become 3. Then there was the Speedmaster. And I want to be clear, it didn't emerge untouched. Its accuracy changed during testing, its luminous material was damaged. The watch carried evidence of what NASA had put it through. But when the final test was over, the watch was still running. The chronograph still operated. The watch could still perform the function that NASA needed. It could measure time. That distinction matters. NASA wasn't searching for a watch that would remain cosmetically perfect. It was searching for one that could continue to do its job even after the conditions around it had become almost impossibly hostile. The Speedmaster did not win because nothing happened to it. It won because everything happened to it, and it still worked. In 1965, NASA qualified the Omega Speedmaster for all crewed space missions. It had entered the laboratory as a commercially available racing chronograph, and it left as official mission equipment. But qualification existed on paper. Trust would have to be earned somewhere else. Inside a spacecraft, on top of a rocket, and eventually on another world. A laboratory can reproduce heat, cold, vacuum, vibration. It can search for weaknesses and push a machine toward failure. But there is one thing a laboratory cannot fully recreate: what it means to trust that machine when you're leaving Earth. After qualification, the Speedmaster stopped being the watch that simply survived NASA's tests. It became part of the equipment the astronauts carried with them, a mechanical timer operating independently from the spacecraft around it. The electronics could belong to the capsule, the computers could communicate with mission control, but the watch belonged to the astronaut. It was physically attached to the person whose life might depend on accurately measuring time. Mission after mission, the Speedmaster moved farther from the world it had been designed to inhabit, away from racetracks, away from engines, and away from the Earth. Then, in 1969, it reached the surface of the Moon. At that moment, the Speedmaster became something that no marketing department could have invented: the first watch worn on the Moon. The racing chronograph completed a journey its designers could have never predicted. And that might be the most extraordinary part of the story. The engineers who created the Speedmaster were not solving problems for NASA. They weren't imagining lunar modules, rocket launches, or astronauts stepping onto another world. They were trying to build an exceptionally dependable chronograph of movement that could time accurately, a case that could withstand real use, components strong enough to continue operating when the conditions became demanding. They could strengthen a spring, refine a gear, improve a tolerance, make one tiny component slightly more dependable than it had been before. Not because they believed the watch would travel to the Moon, but because they believed every detail mattered. Then years later, NASA obtained their work, tested it to discover where it could break, and found something that engineers themselves could not have known. They had built more capability into the Speedmaster than the world it was designed for would ever require. NASA did not turn an ordinary watch into something extraordinary. The tests revealed that the engineering was already there, hidden inside a commercial chronograph, waiting for a challenge large enough to expose it. I think that may be one of the greatest compliments an engineer could ever receive. Not, "You build exactly what we asked for," but "You built something capable of far more than anyone knew." The engineers created the Speedmaster. NASA discovered what it could become, and the Moon gave it a name that the world would never forget. But making history created a new problem for Omega, because once a watch becomes this important, how do you change it without losing it? By 1969, the Speedmaster had earned a place in history that no other watch could claim. But icons create their own kind of pressure. Do you preserve the Moonwatch exactly how it was and risk allowing it to become a museum piece? Or do you modernize it and risk destroying the identity that made people care about it? For Omega, the moon landing was not the end of the challenge. It was the beginning of a new one. How do you improve an icon without replacing it? Now, this isn't the exact watch that NASA tested, and it's not pretending to be. The movement has evolved, the materials have improved, its resistance to magnetism is dramatically better. It meets far stricter modern standards for accuracy. This version has a sapphire crystal, and also a display case back that allows you to see the movement working inside. Those modern upgrades weren't part of the watch worn during Apollo, and yet the connection is immediate. The black dial, the 3-register layout, the case shape, the manually wound chronograph movement. One glance and you know exactly what it is. And that may sound simple, it isn't. Because changing a watch is easy. New materials, new technology, new proportions, a completely new design for a new generation. Watch companies do it all the time, but improving something while preserving the reason why people loved it requires restraint. You have to understand which parts are simply old and which parts have become part of the watch's identity. Change the wrong detail and the connection disappears. Change nothing and eventually the watch stops moving forward. That is the tightrope that Omega has been walking for more than half a century. The Moonwatch could have become larger, more automated, more flashy, or completely unrecognizable. It could have followed every new trend that passed through the watch industry. Instead, Omega allowed the engineering inside the watch to move forward while its character remained familiar. People are not buying this watch because it's the most advanced device available for telling time. A phone can do that, a smartwatch can do that. And they are not buying it to simply own a replica of something from 1969. They are buying something modern that still feels connected to the machine that created the legend. It carries the shape of the past without being trapped inside of it. And that is why the Moonwatch has survived technological revolutions, changing fashions, and generations of newer chronographs. Not because Omega refused to change it, but because Omega learned how to change it without making it feel like something else. The watch NASA tested belonged to its time, and this watch belongs to ours. But when you wind it, start the chronograph, and watch those hands begin to move, the distance between them suddenly feels very small. Most watches are replaced by something newer, but every once in a while, a watch becomes connected to something larger than itself. The Speedmaster began as a racing chronograph. NASA discovered what it could do. Astronauts carried it beyond Earth, and somewhere along the way, it stopped being only a watch. Maybe that's why collectors rarely see Speedmasters as simply different models. They see different chapters. A mission, an astronaut, an anniversary, a moment in Omega's history. The Moonwatch was not loved because it emerged untouched. It was loved because it remained dependable. And more than 60 years later, Omega is still building it, collectors are still chasing it, and people who may never stand near a rocket can still wind one onto their wrist and feel connected to the moment human beings first stepped onto another world. NASA tried to destroy this watch. Instead, it revealed what the watch had been all along. And the moon gave it a story that still has no ending. If you enjoyed this video, make sure you like and subscribe. And remember, a good watch tells time, but a great watch tells a story. I'll see you guys in the next one.